Alright, and welcome to the ultimate guide to transforming standard to vertex form of a quadratic. Now 1a says transform the quadratic function below from standard form to vertex form. So the first thing that we want to know is, what is standard form? Well, standard form is when you're in the form of ax squared plus bx plus c is of course equal to your function f of x. And what is vertex form? Well, vertex form is when you're in this kind of form here, a parentheses x minus h squared plus k. Okay, and we want to transform from standard form into vertex form. And this is going to involve like a really interesting little trick that you've never seen before. But once you master that one little bitty trick, this actually becomes pretty easy. So let's go ahead and tackle this. Okay, in order to transform something, a quadratic, from standard to vertex form, what we're going to do is we're going to write f of x is equal to x squared plus 6x minus 2. And my goal is to turn this into a perfect square. More on that in just a second. The only thing I want you to really understand is that this negative 2 here is actually preventing me from turning this into a perfect square. So I'm going to call this a non-perfect constant. We'll say that this non-perfect constant is really kind of messing everything up. Okay, so then let's go ahead and write it like this. F of x is equal to x squared plus 6x. I'm going to write that in parentheses. I'm going to leave a space. I'm going to put that minus 2. We're just going to kind of shove it to the right. So let me say that one more time. The negative 2 is messing everything up. So we're just going to push that negative 2 to the right. So then the question becomes, well, what do I do to create a perfect constant? What do I do to create a perfect constant? And this is the one trick you're going to have to really remember. We have this little bitty formula called b over 2 squared. So when I look at this, what is my b term? Well, we know this is my a term, this 1 in front of x squared. This is my b term, and that's my c term. So my b term is positive 6. So I have 6 over 2 squared. Well, what's 6 divided by 2? That's 3. And what is 3 squared? 3 squared means 3 times 3, which is 9. And so what I'm going to do is add a perfect constant of 9. So that's our cool little trick. This is the thing that you have to memorize. B over 2 squared. But you can't just add a positive 9 out of nowhere. It's imbalancing the equation. So in order to counterbalance this positive 9 on the right hand side, we're actually going to add a negative 9. Okay, so that's kind of weird. Now in this next step, we're going to do two things. Okay, the first one is this. We're going to go ahead and we're actually going to factor that. And I'm going to show you kind of an in-between step. And this will be the only time I ever show you this in-between step. But if I were to factor x squared plus 6x plus 9, I'd be really saying, we have x plus or minus a number times x plus or minus a number. And the first thing we'll do is say, hey, negative 2 minus 9, that's negative 11. Let's just combine our like terms. And here we're saying, well, what two numbers multiply to be 9 and add up to be 6? In fact, I would ask you to pause the video. Think about that. What two numbers multiply to be 9 and add up to be 6? And the numbers are 3. Hey, that's pretty cool. Positive 3 and positive 3. And wait a second, we noticed that those two expressions are the exact same. So we can do a really cool thing here. We can write this as x plus 3 times x plus 3, or because it's being multiplied by itself, x plus 3 squared minus 11. And here's the thing that I want you to really key in on. What if you wanted to skip this step? Well, you just say, hey, what is half of 6? Half of 6 is 3. So you can literally just jump from here by writing parentheses x, leave a little space, parentheses squared. Those things in green will always be here. And to determine the number that goes right here, the number added or subtracted from x, you just take half of the b term. And this is in vertex form. If I were to ask you, where is the vertex of this problem, it would be incredibly easy. You would say, you know what, the opposite of positive 3 is negative 3, comma, and my y value must be negative 11. So I know the vertex of this quadratic is at negative 3 comma negative 11. All right, let's go on to a second example. Okay, here we have our second example, and I kind of want to really speed this up and show you how quickly and easily this process can be done. So let's write f of x is equal to x squared minus 8x plus 3. And remember, our goal is to turn this into the form of a parentheses x minus h squared plus k, or vertex form. Okay, the thing that's preventing this from being a perfect square is this positive 3. So remember, what's our rule? If it's unhelpful, we are simply going to push that 3 off to the side. Like, we literally just say, you know what, we don't want you in this problem, you go over here. And then this brings us to our trick. How do you create a perfect constant? What do you do? Well, we're going to say, you know what, this is my b term, and our trick is b over 2 squared. Remember, this is something you have to memorize. So I now say, okay, you know, I have negative 8 over 2 squared. And I say, you know, negative 8 divided by 2, that's really negative 4 squared. And what is negative 4 squared? Well, negative 4 times negative 4 has built into it a negative times a negative, which is a positive 16, because 4 times 4 is 16. Okay, so we're going to add positive 16. We're going to create our perfect constant. But you have to balance the equation. So what's the opposite of positive 16? Well, that's going to be negative 16. And so let's go ahead and write this. We'll say, okay, you know what, f of x is equal to, and I told you that we were going to skip that prior step, so let's check it out. This is what you always draw. You always draw parentheses x, close parentheses, squared. We know 3 minus 16 is, of course, negative 13. And then the question becomes, well, you know what number am I adding or subtracting with x? And the answer is always half of your b term. So what is half of negative 8? That is negative 4. And there you go. There's our answer. There is our vertex form. Now, you also have to determine where is the vertex. Let's call this 2b. And remember, our vertex is this value of x that makes this negative 4 equal to 0. So what's the opposite of negative 4? Positive 4, comma, negative 13. Boom, we have our vertex. Easy. All right, let's do one more. I know this is such a weird thing the first time you see it. So let's do one more example. Okay, here we have f of x equals x squared minus 2x minus 13. And once again, what are we going to say? We want to turn this from standard form into vertex form. And this negative 13, just trust me on this. Every constant you're going to see is essentially going to be a non-perfect constant. A non-perfect constant. And so let's just go ahead and tackle this. We know that our trick is to say, you know what? We're going to write f of x equals parentheses x squared minus 2x. Leave a space, and we literally just push that negative 13 as far to the right as we have to. We're just pushing it out of the way. Now, what in the world is our trick? Well, we know that our trick for creating a perfect constant is going to be, b over 2 squared. Remember, you have to memorize this, b over 2 squared. And what's our b term? Well, our b term is this negative 2. So I have negative 2 over 2 squared. And negative 2 divided by 2 is actually negative 1 squared. And negative 1 squared really means negative 1 times negative 1. A negative times a negative is a positive 1. So we can write plus 1. And to keep this balanced, the opposite of plus 1 is, of course, minus 1. Okay, so let's go ahead and go from left to right. We'll say f of x is equal to two things. One, we're going to transform this into our perfect square, x plus or minus some number squared, and negative 13 minus 1 is negative 14. And here, we just want to say, what is half of our b term? What is half of negative 2? Well, that would be negative 1. And there you go. There is our vertex form. Now this takes us to part 3b, and where is the vertex? So remember, for our vertex, this x value we want to make this parentheses equal to 0. What is the opposite of negative 1? Well, that would be positive 1, comma, negative 14. And there you go. There is our vertex. Y'all, I hope this helps. If you're confused on anything, because I know this can be a tricky concept, re-watch the examples, and I'll catch y'all in our next video series.